Hello, AP Chemistry students. This is Mrs. Altman. We are on video number 2, Thermochemistry Part 2. Here are our objectives for today's video. Pause here. So we've talked about this a little bit before, but we're just going to get the vocabulary into our notes. The first is that the system is the part of the universe that we are focusing on. So in most cases in the chemistry lab, that is going to be 3 styrofoam cups with a thermometer that is touching whatever the reaction mixture is. And then the surroundings are literally everything else in the entire universe that has any sort of corporeal form. Pause here. So in the explanation, I'm actually going to start with the last point that's here, that the breaking of bonds is always endothermic and the forming of bonds is always exothermic. If those two things are, for whatever reason, not true, then the bonds will not break or will not form. So in an endothermic reaction, heat flows into the system. That means that more energy was required to break the bonds than was released forming bonds. So the products have less stable bonds than the reactants. Q is going to be greater than 0. You will also sometimes see H used instead. We'll talk more about that. In an exothermic reaction, the opposite is true. Heat flows from the systems to the surroundings. Therefore, the surroundings feel hotter. The products have more stable bonds than the reactants because more energy was released forming the bonds than was absorbed breaking bonds. Q is going to be negative in that case. Pause here. I'll say the answers out loud in 5 seconds. A is going to be exothermic. If it did not say elemental, then you would have to do a calculation that you haven't learned how to do yet, but we are forming a bond, therefore it is exothermic. B, that is endothermic. You have to add heat in order to in order to boil water. And any combustion reaction is very exothermic. We know that because we can feel that the surroundings get very hot. Pause here. You don't need to draw all the details of the picture. So we're going to be talking a lot about potential energy diagrams, not just in this section of the class, but also later on when we get to chemical kinetics. Potential energy diagrams, they show the energy of the reactants versus the products, as well as any intermediates or transition states. We'll talk more about what those mean as we look more in detail in class. But what we're seeing here, the first one to the left, that is an endothermic reaction because the overall delta H, which we can use more or less interchangeably with Q, that just means enthalpy, which can be used interchangeably. And to the right is an exothermic reaction because the overall products are lower in energy than the reactants. Pause here. All right, so I'm going to say the signs out loud, and then I'm going to sketch the reactions. For an endothermic reaction, delta H is positive because we can use it interchangeably with Q. And then for an exothermic reaction, delta H is negative. So I'm going to draw the diagrams. It's pretty much the same diagrams as were the prior slide. So for an endothermic reaction, the only important thing is that the products are higher in energy than the reactants. And for an exothermic reaction, the only thing that is important is that the products are lower in energy. There were other ways I could have drawn it. I could have drawn it like that. I could have drawn it with multiple steps. There's a number of different ways that would have worked. And then here are our additional practice problems. Thank you so much for watching and have a great night.